που θα μας μιλήσει για αυτό που ακριβώς που συζητάμε, την CAL τεχνολογία και πώς κερδίζουμε χρόνο κερδίζοντας τον έλεγχο.
Everyone, my name is Niklas. Hello everyone, my name is Niklas Lindberg. I am the sales director at Resuscitech. Unfortunately, I cannot be with you today due to the fact that we are actually at the EuroELSO in Krakow. I hope that you enjoyed the exchange with my colleague, Dr. Stefan, earlier. So now I will just quickly go through the technology and the product itself. Okay, so let's quickly, in 10 minutes, go through the technology and the product itself. In the picture here, you see our three pillars in the therapy itself. So it's the call controller, it's the call MOX, call cooler, and here on the picture, the call controller is standing on a transportation rack, which is used for transports. The call is actually, as you are informed by Stefan earlier, a therapy which we then enhance to a product. And with the product, we aim to deliver a high pulsatile blood flow. We have a possibility of a rapid cooling. We have a special priming solution that has a high osmolarity. And with the MOX, we can actually target the oxygenation. We also have a special fiber optic cable where we can measure the high blood pressure that we are delivering to the patient. And if we are in a special situation where we need to measure blood gases, we actually have a small cartridge which we can insert in the controller itself to measure blood gases. We also apply the concept of mobility. So we know that the cardiac arrest patients, they can be transferred from out of hospital or they can be transported in the hospital. And now we are coming to a schematic animation which actually explains the slight difference from call compared to a conventional ECMO system. So if you follow the blood flow on the venous side, the blue side, then you come to pump 1. And here, all the way to the oxygenator, it looks very similar to conventional ECMO. And from the oxygenator, the pre-ox side above, on top of the oxygenator, we have the possibility of applying a manual dosage system. And that dosage system is intended to be used for applying vasoactive drugs, continuous heparin infusion, or maybe if you want to have some additional volume to the patient. Then we of course have the gas supply, which also can be done with the normal gas mixer, but we recommend using the call MOX because then you have the mobility concept. We only need 1 bottle of oxygen because the MOX itself is a small ventilator, so it will compress ambient room air. Just set the sweep gas flow and determine the FiO2 and good to go. On the lower side of the oxygenator, we have the possibility of adding the cooler. So in our setup, it's just a cooling, but of course it's conventional Hansen connectors on the oxygenator, so you can apply whatever heater cooler unit that you have in the clinic. From the post-oxy side, it's where the most interesting parts are happening in the CARL setup. Here we have the possibility to use the blood gas cartridge if we are in an environment where we want to control the blood gases. Of course, if you're in the clinic and you have access to your point of care devices, you don't need it. Pressure number 3 is post-ox pre-pump 2. And that is important to understand that pressure 3 in this setup is not the arterial pressure as you see in conventional ECMO system. Rather, for us, it's just a technical measurement where we want to make sure that pump number 2 never goes faster than pump number 1, and therefore applying a negative pressure on the oxygenator, which could be potentially dangerous. On the arterial line, you then have this flow sensor and the bubble detection. And on the very distal side, shortly before the arterial cannula, you have the 45 degree angled luer connection where we can insert the fiber optic cable up to the descending aorta to measure the pressure that we are delivering to the patient. Here is just some pictures on the controller itself. So you see the dual pump on the left-hand side, and you have a nice, quite large interface for controlling the patients. Just an overview, and you see the pressure curve applied by the fiber optic cable in the middle. It's very similar to an IABP. Here is the reperfusion set, so similar to an ECMO set. Of course, we have the double pumps, which is already there. Then we have a priming bag, which is patented, so we actually can connect the tubings underwater and therefore have a closed loop. It's really a plug-and-play system, so all the sensors are in the lower multifunctional plug, so you just click it in and then good to go. The priming solution itself, it's containing mannitol, sodium citrate, and magnesium. We have a total priming volume of the set of 890, but for the priming procedure, we recommend to have 1600 milliliters of solution in there. Heparin is always recommended, and the normal ACT levels is similar to ECMO, so recommended is 180 to 220 according to the ELSA protocol. The arterial blood gas analyzer can be inserted on the right-hand side of the controller. Then we just have a small shunt line from the arterial side or post-oxy side of the oxygenator to connect. It will calibrate itself, and it allows up to 25 measurements. Looks like this. Here is then the arterial pressure sensor. So it's a fiber optic sensor. We insert it in the luer 45-degree luer connection on the distal side of the arterial line shortly before the cannula. It goes up to the descending aorta, and we get a real nice measurement of the blood flow and the blood pressure that we are delivering to the patient. Since we are using a pulsatility mode for the first 45 to 60 minutes, here's also a point where we actually can see when the patient is tending to have a normal ejection or a native ejection itself. Then we will immediately recognize that on the augmentation curve, and that's the point of stopping pulsatility. Carl-Mox, it's a very mobile gas mixer, as earlier explained. So the upside here is that we only need to use one bottle of medical oxygen, and it will compress ambient room air itself. Set the sweep gas flow on the left-hand side, determine the FiO2 on the right-hand side of the menu, and then we're good to go. The cooler, and here is the hardware part of the cooler, where we have a small roller pump. We have a battery which is compatible with the controller. Everything is packed in a bag, very ready for usage in the pre-hospital setting. And the upside with the Carl cooler is that we actually have a disposable kit, so no need for manual cleaning protocols. Everything is packed in a disposable kit. On the very top, we have tapped filtered water. In the bottom, we have urea granulate. So when we pull out that red thing in the middle, we will have a chemical endothermic reaction. And the reference is that we can lower a male 80 kilograms 3 to 4 degrees within 10 to 12 minutes. So it's extremely powerful, and it's a nice tool if you are believers of a rapid cooling procedure during cardiac arrest. So I would just like to round up and say thank you very much for having us. Unfortunately, we are not there in person, but really hope to come out and visit some of you in the clinics in the future. So thank you very much for having us.
Υπάρχουν ερωτήσεις από το ακροατήριο? Τότε, αν συμφωνεί και ο Συμπρόεδρος, ο κύριος Αναγνώστου, σας ευχαριστούμε πάρα πολύ για την προσοχή σας. Ήταν πραγματικά ένα πάρα πολύ ενδιαφέρον στρογγυλό τραπέζι. Παρουσιάστηκαν νέες τεχνολογίες τελευταίας αιχμής. Μακάρι μερικές από αυτές να δούμε και στη χώρα μας όσο πιο σύντομα γίνεται. Και ευχόμαστε καλή εξοικείωση με την καινούργια τεχνολογία και καλή εκπαίδευση. Καλή συνέχεια στην ομάδα εργασίας. Κύριε Αναγνώστου.
Καλά, τίποτα. Αυτό θα το δούμε το πάνω το μηχάνημα, αυτό πώς δουλεύει και θα το δούμε καλύτερα. Καλά. Ευχαριστούμε.